Hello students, welcome to Iit Foundation. So myself, I am Shivashankar, I am a physics teacher. Today we are going to see the next continuation of chapter, that is collisions. We are discussing about the collisions now. So in the last class we have completed two types of collisions, perfectly elastic collisions and perfectly elastic collisions we have completed. Then today we are going to see there head-on inelastic collisions, we will see there. Okay, perfectly elastic collisions we have completed there. So head-on collision and oblique collisions were completed. So here now we will see there inelastic collision. So today we are going to see about the inelastic collision. This is synopsis 5. So in this chapter, in the this one, in the collisions and center of mass and collision, it is the last chapter. Okay. Next we will go for the next chapter. Okay. So now here synopsis 5. Synopsis 5 then, okay. So inelastic collision, perfectly inelastic collision, perfectly inelastic collision, inelastic collision, okay. So we know that elastic collision is nothing but, we know that, and inelastic collision is nothing but, so the collision in which both kinetic energy and the kinetic energy and linear momentum will be conserved, and this kinetic energy will not be conserved. So then that collision is called the inelastic collision there. Elastic collision means both kinetic energy and the linear momentum will be conserved there, constant, okay. So before action and after the action, otherwise we can say that before collision and after the collision, the both kinetic energy, total kinetic energy of the system is constant, and even the kinetic energy also it is constant there. That is the elastic collision. So now here we are going to see in this chapter, it is the inelastic collision. We know that no, in inelastic collision, the kinetic energy will not be constant there before and after collision. There is a loss of kinetic energy will be there, okay. So only the linear momentum will be constant there. Only linear momentum will be constant. So now here we'll see there what is the expression for that linear momentum, and so if energy loss will be there in the kinetic energy, then what is the expression for the kinetic energy we'll see there. Later we'll see there perfectly inelastic collision. Perfectly inelastic collision we are going to see now here, okay. So now in this collision, in inelastic collision, the linear momentum only the conserved, means before collision the body has, so before collision the body has the mass m1 and initial velocity u1, and another body, so mass m2 and velocity of that body will be u2, and it is moving in the same direction. Suppose if you take that, so during the collision they will be, so they will be collide each other. So after the collision they will be move with different velocities. Both the objects will be moved with different velocities, mass m1 and here v1 we can write, and another body has the mass m2 and v2, m2 and v2 we can write there, m2 and v2, okay. So here then the total linear momentum will be constant there. So this is a before collision. So before collision, there is a linear momentum, that is a P initial, that is m1 u1 plus m2 u2, we can write here m2 u2, and after the collision, so after the collision, the final linear momentum can be written as here m1 v1 plus m2 v2, we can write that, m2 v2. So now according to the law of conservation of linear momentum, we can write like this, the equation will get there m1 u1 plus, so m2 u2 is equals to m1 v1 plus m2 v2, m1 v1 plus m2 v2. This is the expression for the linear momentum in the inelastic collision, okay. So now we'll see the expression for the kinetic energy. So we know that in the inelastic collision there is no, the kinetic energy will be conserved, okay. So then there is a loss of kinetic energy will be there. So that loss of kinetic energy can be written as like this. So before collision there is a kinetic energy, we can write here initial kinetic energy, that we can write here half into, so m1 u1 square plus half into m2 u2 square. So here we can write there kinetic energy. Kinetic energy. Kinetic energy by the law of conservation of energy. LC, law of conservation of energy. So here we'll get there half into m2 u2 square. Okay. Then after final kinetic, after the collision, there is a final kinetic energy will be there, that is half into, so m1 v1 square plus half into m2 v2 square, plus there is a loss energy will be there. That loss can be, here it is written as Q. This is the extra energy. Okay. How much loss of energy will be there. Other form of energy like sound, heat in the form of deformation, that one. Okay. So now according to the law of conservation of energy, linear kinetic energy is equals to final kinetic energy. We can write here. So now linear kinetic here, initial kinetic energy half into m1 u1 square plus half into m2 u2 square. It is not equal to this final kinetic energy, but there is a certain loss of energy will be there, that is in the form of heat or deformation or okay. So that can be written as here half into m1 v1 square plus half into m2 v2 square plus this is a energy here we can add there. So this is the expression for the kinetic energy in the inelastic collision there. So here Q will be in the form of, this Q is nothing but heat energy or we can say sound energy, and the deformation force. Okay. So that may be the deformation energy there. So this is expression for the kinetic energy. Now we are going to see the perfectly inelastic collision there. Okay. Perfectly inelastic collision. Perfectly inelastic collision. So perfectly inelastic collision means, okay. So we can write here same, we can write there. So after the collision, both kinetic energy and the linear momentum, only the kinetic energy can be conserved there constant before and after collision, but we know that the linear energy will not be constant now. Okay. So then here in inelastic collision, that is the case there, both will not be, means this linear kinetic energy, linear momentum will not be constant and kinetic energy will not be, linear momentum will be constant in the inelastic collision, then kinetic energy will not be constant then. Okay. So here perfectly inelastic collision means, so their linear momentum will be conserved, but here after the collision the two bodies will be stick together and they will be move with common velocity. So that collision is said to be the head-on perfectly inelastic collision there. Head-on perfectly inelastic collision there. So after the collision they will be stick together and combined, and they will be travel with the common velocity. So that is said to be the perfectly inelastic collision there. So suppose if they are moving, then according to the law of conservation of linear momentum, okay. So then here we can write the initial momentum is m1 u1 plus m2 u2, that is equals to, here we can write the m1 v1 plus m2 v2 there. Okay. In the perfectly inelastic collision, so after the collision two body will be stick together and they will be move with certain velocity. So then here we can write there v1 is equals to v2 is equals to, if you write here v, then from this equation we will get there m1 u1 plus m2 u2 is equals to m1 plus m2 into v will get there, m1 plus m2 into v. So from that we can write here v is equals to, then common velocity here we can write there, so m1 u1 plus m2 u2 divided by, So here we can write there m1 plus m2, m1 plus m2. This is a common velocity. This will be the common velocity. Okay, it is the common velocity. So now we can add the kinetic energy now. Okay, so kinetic energy. So here the kinetic energy we can add the initial kinetic energy. So half into m1 u1 square plus half into m2 u2 square we can add there. m2 u2 square we can add there after the collision. So what can we write here? This is the initial kinetic energy we can add there, and final kinetic energy here we can add there half into m1 plus. They are moving with the common velocity, no? So then mass of the body here it can be written as mass of the body is m1 plus m2, m1 plus m2 into v square we can add there, m1 plus m2 into v square. Okay. So this will be the final kinetic energy. Now here we got there v1 value, what we got there, this whole thing we got now. So if you write that, there we'll get that equation. So we'll get like this. Then final kinetic energy we can write here half into m1 plus m2 into v. V value what we got here, v is nothing but m1 u1 plus m2 u2 divided by m1 plus m2 whole square. V square is nothing but whole square will get there. So now from this half into m1 m2 into, here we can write like this, no? So m1, this is u1. So m1 u1 plus m2 u2 divided by m2 u2 divided by whole square, and here separately I am writing here m1 plus m2 whole square we can write there. So numerator and denominator we can write separately. Then this value and this value will be cancelled now. Okay. So m1 plus m2. Here m1 plus m2 whole square is there. m1 plus m2 into m1 plus m2 we can write there. One m1 plus m2 will be cancelled, and the remaining will be the kinetic energy. Final kinetic energy equation we can write here half into. So m1 u1 plus m2 u2 whole square. m2 u2 whole square divided by, so m1 plus m2 will get there, m1 plus m2. This is a expression for the final kinetic energy in the perfectly inelastic collision there. Perfectly inelastic collision. Okay. So now the change in kinetic energy. So change in kinetic energy, how much loss in the kinetic energy. Okay. So that it can be written as here change in kinetic energy. So that it can be written as here initial kinetic energy minus final kinetic energy. So we can write like this, initial kinetic energy minus final kinetic energy. So initial kinetic energy, what is the equation we got here? Initial kinetic energy equation is this one. So this is the initial kinetic energy. This will be the initial kinetic energy. And the final kinetic energy, what we got here? This will be the final kinetic energy there. Substitute here now, we'll get the answer there. We have to simplify that, we'll get the answer here. So half into, so m1 u1 square plus half into m2 u2 square minus, so final kinetic energy is this one, no? Half into m1 u1 square plus m2 u2 square, m2 u2 whole square divided by here m1 plus m2. So if we simplify it, so we'll get the final equation, that is the, so change in loss in the kinetic energy, loss of kinetic energy during the perfectly inelastic collision there, when the two bodies are stick together and moving with common velocity in the perfectly inelastic collision there. Okay. So then here we'll get the equation as here half into, so m1 m2 divided by m1 plus m2 into, here we can write u1 minus u2 whole square, This is the final expression after the simplification of this equation. So how to simplify here m1 plus m2? So we should multiply here. LCM will come now there. m1 plus m2 LCM will come there. So remaining all the quantities will be cancelled here. m1 u1 square, m1 u1 square. This is a m1 u1 square will be there. So these terms will be cancelled there. After some quantities, some terms are going to be cancelled after the cancel, then this is the final equation we get there. That is half into m1 m2 divided by m1 plus m2 into u1 minus u2 whole square, u1 minus u2 whole square. Okay, that is the expression we will get there. That is the loss in kinetic energy. So, in perfectly inelastic collision, there is no loss in linear momentum, only loss in the kinetic energy will be takes place there. So, next one, next concept, it is coefficient of restitution, coefficient of restitution. Okay. Next one, coefficient of restitution. Coefficient of restitution. Okay. So, restitution is nothing but in the last class we have derived the expression, okay, for the final velocities of the body in the perfectly elastic collision. Okay. So, there what we got the equation there, velocity of approach, velocity of the approach and velocity of the separation we got now. So, here this coefficient of restitution is, it is nothing but, so ratio of velocity of separation to the velocity of approach is called the coefficient of restitution. Okay. So, what is the coefficient of approach we got there? So, velocity of approach. Okay. Simply we write here velocity of approach. So, velocity of approach what we got? Velocity of approach in the perfectly elastic collision. We have derived the equation of final velocities of the two objects which are collided. Okay. After the collision they will be moved with different velocities, and we got the V1 and V2 values there. So, there before that by using the law of conservation of linear momentum and the law of conservation of energy, we got the certain equation there. From that equation we have found the relation between V1 and final velocities we got there. Okay. So, there velocity of approach we got there. So, velocity of approach. So, what is the velocity of approach we got? That is u1 minus u2 we got there. Okay, u1 minus u2 we got now. So, next velocity of separation, velocity of separation. So, velocity of separation what we got there, here, there. So, v2 minus v1, v2 minus v1 we got now, v2 minus v1 there. Okay, now here the coefficient of restitution is nothing but it is the ratio of velocity of separation to the velocity of approach of a collided objects is said to be the coefficient of restitution. Okay. So, means here we can say like that now, this velocity of here we can write like this, velocity of approach is directly proportional to the velocity of separation, velocity of separation. Okay. So, if you remove this proportionality we will get a constant. Okay. So, this is a velocity of approach, velocity of approach directly proportional to the velocity of separation, velocity of separation. So, from this we can write here velocity of approach what we got there here, u1 minus u2 directly proportional to here v2 minus v1 we can write now. So, now here if you remove this proportionality we will get constant now. So, that is equals to we will get here E. So, that coefficient of restitution it is denoted by the letter E, small e. Then here we can write here v2 minus v1, v2 minus v1 we can write now. So, from that E is equals to, or we can write like this also, this equation, this expression. So, E is equals to, even we can write like this now. Okay. So, this equation we can write here. So, v2 minus v1 is directly proportional to u1 minus u2. Okay. Velocity of separation is directly proportional to the velocity of approach. So, then from this what can we write here? So, v2 minus v1, if you remove this proportionality we will get a constant, that is a E. So, here we can write there u1 minus u2 we can write there now. So, from this E is equals to what can we write there? E is equals to v2 minus v1 divided by v2 minus v1 divided by u1 minus u2, u1 minus u2. So, this is the expression we got there. So, this expression is nothing but the coefficient of restitution, coefficient of restitution. See here, this is the velocity of separation, or it can be defined as the velocity of separation of the two colored object velocity of the separation of the collided object to the velocity of separation. Okay, so velocity of the separation after the collision of the objects to the velocity of approach before the collision. So that is the ratio is said to be the coefficient of restitution. Like this also we can define there. Okay. So now if this coefficient of restitution, if it is greater than 1, so if it is equal to 1, if this is equals to 1, if E is equals to 1, we can say it is if E is equals to 1, that implies it is the perfectly elastic collision, perfectly elastic collision. Okay. If E is, so if E is less than or equal to 1, or if E in between the 0 and 1 there. Okay. So if E is equals to 1, it is said to be the perfectly elastic collision there. So now if it is E is in between, if E is in between 0 and in between 1, so then we can say it is inelastic collision. The body is inelastic collision. It is said to be the inelastic collision. Okay. By using this coefficient of restitution, we can say whether that collision is elastic collision or inelastic collision there. Okay. If it is completely inelastic, then E will be 0 there. Okay. If it is a completely inelastic, then E will be 0. If it is E is 0, if E is 0, then there is a completely inelastic collision there. Completely inelastic collision means we can say that is a perfectly inelastic collision there. So this is inelastic collision. So where the coefficient of restitution in between the 0 and the 1. Okay. So that is about the coefficient of restitution. So now if velocity of approach, see here we have seen there this u1 and u2, u1 minus u2 when they are moving in the same direction, and velocity of separation they are moving in the same direction. After the collision also they have moved in the same direction there. So then what will be velocity of approach while they are moving in opposite direction there? While they are moving in opposite direction means, so a u1, so a car A is moving, okay, ahead of car B. So this is a car A is moving and car B is moving there. If the car B velocity is more, then both will be moved and they will be collided after certain time there. Okay. So then if they are moving, so this is also approach only. We can say this is approach. So B is approaching to the A. So it is a velocity of approach we can add there. Okay. So VA minus VB we can add there, velocity of approach there. So now they may have the approach in between. They may come moving towards each other there. So that is also velocity of approach there. Means they are moving towards each other means they are moving in opposite direction. Means velocity of one body is opposite to the direction of the velocity of other body will be in opposite direction there. In that case, the velocity of approach, how it can be written? So it can be written like this there. So if the collided bodies, colliders are moving in opposite direction, if they are moving in opposite direction, then the coefficient of restitution. So here we can add their first we should see their velocity of approach. Velocity of approach we can add here. They are moving in opposite direction means, so there is a relative velocity u1 plus u2, no? So u1 plus u2 we can add there, u1 plus u2. So in the same way, velocity of separation is also, so v1 plus v2 we can add there, v1 plus v2. Okay, but so it may be negative. Okay, sign will become there negative there. So now here we can add there. Now coefficient of restitution in this case, velocity of separation v1 plus v2 divided by u1 plus u2 we can add there. So this is another case. So E is equals to V1 plus V2 divided by U1 plus U2. We can write there when they are moving in opposite direction there. So this inelastic collision, this coefficient of restriction is a unitless and dimensionless quantity because it is a velocity. Velocity of approach or velocity separation or velocity of approach, both are velocity. They will be measured in meter per second only. So both they will be cancelled there. So we'll get the unitless quantity and dimensionless quantity. So now, so in inelastic collision, velocity of first body after collision, velocity of first body after collision and velocity of second body after collision there. So we have derived there after collision. In perfectly elastic collision, we have got the equation like so m1 minus m2 divided by m1 plus m2 into u1. Okay, v1 is equals to m1 minus m2 divided by m1 plus m2 into u1 plus so 2 into m2 divided by m1 plus m2 into u2 we got them. So now here in elastic collision, here in inelastic collision, what will be the velocity of first body after the collision? So that is there we can write here v1. So v1 in terms of in inelastic collision we'll get the value of this this one E will get there. So that equation we can write here. Equation is m1 minus E into m2 divided by m1 plus m2 we can write here m1 plus m2 into u1. Okay, so there is a equation there plus here m2 minus E into m1 divided by m1 plus m2 into u2 we can add there m1 plus m2 into u2. Okay, so then next velocity of second body after the inelastic collision. After the inelastic collision, this is the velocity of the first body, and after the inelastic collision, velocity of second body. It can be written like this. Okay, that is so 1 plus E into 1 plus E into 1 plus E into here we can add there this expression here 1 plus E into this expression we can add like this 1 plus E into m2 value 1 plus E into m2 will get here 1 plus E into m2 will get there, and here 1 plus E into m1 divided by m1 plus m2 into here u1 we can write plus. So here m2 minus E into m1 divided by so m1 plus m2 into this is m1 plus m2 into u2. So these are the two expressions. For the final velocities of the object in the elastic collision. In inelastic collision, there these are the two expressions. Okay. So now we have derived the equation of the loss of kinetic energy. Then what will be the expression here? Loss of kinetic energy. What is the expression for the loss of kinetic energy in inelastic collision? That we are going to see that now. Okay, loss of kinetic energy in inelastic collision. Loss of kinetic energy in inelastic collision. Inelastic collision. Inelastic collision. Okay. So what is the expression we got there in the first change in kinetic energy? Loss in kinetic energy is delta K we got there. So here that can be written as here half into so m1 m2 divided by m1 plus m2 we can add here m1 plus m2 into so u1 minus u2 whole square we got there u1 minus u2 whole square we got now. So u1 minus u2 whole square we got, and here extra will come there 1 minus E whole square. 1 minus E whole square will come there. This is a loss in the kinetic energy in case of inelastic collision. Loss of kinetic energy in the inelastic collision. Okay, loss of kinetic energy in inelastic collision there. Yes, now next one. So this is let us consider these are the node points. So let us consider this is the first node, okay. And second one here, suppose if a body is dropped from certain height there, so there is a loss of means there is a velocity of approach will be there, and then it will be collide with the ground, and it will be uh, jumps up certain height there. So there is a velocity of approach and velocity of separation will be there. So in that case, so what is the velocity of this coefficient of what is the coefficient of restitution? Okay, that we can see here, that one. So there here, suppose a body is, if a body is fall from certain height there, u, okay, then it will be reach the ground. This it will be reach the height. So that is what there. What is the equation? 2gh, no. In the kinematics we know that whenever the body is falling downwards, then it is falling more. So u will be 0 and a is nothing but g will get there from, and distance it is traveling here h square. So from v square minus u square is equal to as, we will get this value. So it is moving and it is falling on the ground. So with this velocity we can write here. So square root of 2gh we can write there, and with the same velocity it will be reaches. Suppose it may, because of the collision there is a loss, maybe the velocity, the loss in the velocity maybe takes place there, then here v1. So v1 will be different there. So here this can be written as here. So this is a u1, and you can write this as a u2, okay, this as a u2, because this is a velocity of approach there. Then after rebounding, it will be rebounds up to certain height, no, it will be rebound up to certain height there, okay. So this first height we can write here h1 we can consider there, and in the rebounding case, due to certain amount of energy can be lost, so then it will be rebounds to up to certain height, that may be here h2 we can write there, h2 height. So with the same velocity it will be reaches there. So now if it is a h2 height, then here we can add there. So now here in the case of separation, this will be the velocity, initial velocity, and here the final velocity we can add here, that is for h2 we can add like this, v is equals to, otherwise we can add here u1, no? So we can add here v1. So v1 we can add here square root of 2 into g into h2 we can add there, okay. So now after reaching h2, that is what will be the final velocity? The final velocity will become 0, no? Final velocity will become 0, okay. v2 will become 0. See here, u1 will be 0 while it is approaching, and there here this one will be in separation. In the separation, this v1 will be the 2gh2 and v2 will be 0 there. After reaching certain height, again it will be fall on the ground there, okay. So means here u1 is 0 and u2 is square root of 2gh1 and v1 is square root of 2gh2 and v2 is 0 here. Now if you write the formula here, E is equals to v2 minus v1 divided by u1 minus u2, we got, no, u1 minus u2. So now what is here v2, v1 what we got there here, v1. So here minus square root of 2gh2 divided by, and what is the u2 here we got there, so u2, so u1 is 0, no, okay. So v1 is what there, v1 is this one we have written there, and v2 is 0 here, that v2 is 0 we can write, and u1 is what here 0 and minus v2. So u2 what we got there, square root of 2gh1 we can write there. So from this expression, so we'll get here minus square root of 2gh2 divided by minus square root of 2gh1. So what are they going to be cancelled there? Minus and minus will be cancelled. Square root this one, this will be cancelled now here. So this here root into 2g square root of h2 divided by root into 2g square root of h1 will be there. This and this will be cancelled there. Therefore, the coefficient of restitution in terms of height we can add there, h2 minus h2 by h1. This is the expression for the coefficient of restitution in the case of when a body is freely fall and it is rebounding to certain height there. So that is the expression. So now here one more case is there in this. So here this is for one rebound. It is for one rebound. There may be there are n number of rebounds maybe takes place there. So in that case, how this relation it will be? Okay, that we are going to see there. It means H2 is equals to the relation between the coefficient of restitution and this one. Okay, so that we can write here. That is a note. The next note you can write there. Okay, that is the height reached by a body after nth rebound. The height reached by a body, the height reached by a body, the height reached by a body, by a body after nth rebound, after nth rebound, after nth rebound. So that can be written as here Hn, H2, height H2 we can write there. So, or we can write there Hn is equals to e power 2n into H1. We can write this one. So, this is the expression for the height reached by a body in nth rebounds there. So, in the previous note we have seen there, it is only one rebound. For the one rebound, we got that equation there. Relation between the coefficient of restitution and the heights we got there. Okay. So, now this is the it is for nth rebounds. In nth rebounds, if it takes place, that is the expression there. Now the speed of velocity after nth collision with the ground there. So next here one more note is given here. Speed of a body, speed of body after nth, speed of body after nth collision, is given by, it is equals to here. So we can write here Vn is equals to e power n into V1 we can write there. So this is the initial, V1 is what the initial speed and V2 will be the final speed we can have there. So this derivations of this all we can study in next classes. In higher studies we can see there. Then a total distance covered by a body before coming to rest. So total distance. So then it will be take n times of n number of rebounds will be takes place and it will be come to rest. Then total distance covered by the body before coming to rest there. So total distance, sum of the total distance we have to the total distance. So total distance, here we can add there, total distance covered by a body, before coming to rest. After taking the n number of collisions, then it will become to rest before coming to rest, before comes to rest. So that is given by here. So S is equals to H into 1 plus E square divided by 1 plus E square divided by 1 minus E square. So this is the expression. Okay, there is the expression there. These are the formulas we should remember. By using these formulas, we can do the numericals there. Okay. Now total time taken. So this is the total distance we got there. So now even we can find out the total time taken. So total time taken by the body to come to rest. So that is given by T is equals to square root of, capital T is equals to square root of 2h by g. So this is normally time of descent equation we can write there, but here extra we should write here 1 plus E divided by 1 minus E. This is the extra. So up to here. This root will be up to here only. So this is the expression. So square root of 2h by g into 1 plus E divided by 1 minus E. So that is the expression there. Okay. So elastic collisions in two-dimensional plane there. Elastic collision in two-dimensional plane. So that is not required here. You can study in higher studies there. So now we'll see some of the problems there. See here exercise. The coefficient of this conceptual bits we can do there. So now the exercise 1 we'll see there. Exercise 1. Exercise 1. Okay. So in the exercise 1, first problem you see here there. So first solution. First solution. So 1 kg ball moving 12 meter per second collide head on with 2 kg ball moving in opposite direction 24 meter per second there. The velocity of each ball after impact, the coefficient of restitution is 2 by 3. 2 by 3 is there. So velocity of each ball after impact there. After the collision, what is the expression of the final velocities they are asking there. Okay. So the coefficient of restitution is given here. So here mass of the body is given. First mass of the body is here 1 kg, and second and velocity of this body is given there 12 meter per second. 12 meter per second. And second mass of the body has the 2 kg mass, and here initial velocity. So velocity of that it is given. It is coming in opposite direction. So opposite direction means we can write there minus, no? Minus we can take here. So m into m1 minus this one we can take here. Okay. So then coefficient of restitution is given there. Coefficient of restitution. That how much is given there here? It is coefficient of restitution is 2 by 3. 2 by 3. So coefficient of restitution is given 2 by 3. So we got the equation no, just now. So what is the equation we got there? m1 minus e into m2 divided by m1 plus m2 into u1 plus 1 plus e into m2 divided by m1 plus m2 into u2. We got this equation no? Just now we have written there. Okay. In the same procedure we'll approach there we'll get the answer there. In the first step, in the perfectly elastic collisions, what is the procedure we have found there? We have gone through. So then in the same way if you go, we'll get this one. But here we should apply here coefficient of restitution. Okay. So now here substitute here now v1 will get here. So v1 how much you get there? m1. m1 is 1 and this is a 2 by 3 coefficient of restitution. m2 is what here? 2 there. So into and divided by m1 plus m2 there. This will become 3 there. And u1 how much we got there? Into 12. Into 12. So plus here 1 plus e. So 1 plus 2 by 3. 1 plus 2 by 3 into m2 value how much there? 2 kg. So 2. This will be the 2 there. Okay. Divided by, so 1 plus. Here m1 plus m2 no. This will be the m1 plus m2. m1 plus m2. So here also we will get there 3. And into how much we got there? This is a minus 24. Minus 24 we got there. So we can cancel here this one, 4 will come here. This how much? 8 will come no? Minus 8. And here v1 is equals to how much we get there now here? 4 and 3 minus. So here minus 3 and 4 there. Minus 1 minus 3 minus 4. So minus 1 by 3 into 4 we can write here. Okay, plus simplification we have to do there here. Okay, so this is a minus. So here we'll get the minus no this one, because minus here this one, minus 8 is there. So minus 8 into, so minus 8 into, so here how much you get there? 4, no? If you multiply there 4, if you multiply here 4, 1 plus 4 by 1 plus 4 by 3 there, means 7 by 3 will get there. 7 into here, 7 by 3 we can write here. So now, so from this v1 is equals to what can we write here? Minus 4 by 3, minus 4 by 3, and here minus 56 by 3 we can write there. So how much you get there? Minus 60 no? Minus 60 means how much you get there? Minus, this value will be minus 60. Minus 60 divided by 3 will get here. So that will be minus 30 meter per second. Minus indicates it will be moving in opposite direction. So there is a minus 60 we can add there, minus 60. See, minus 30 will get now, minus 30. Okay, so that is the equation we got now. See here. This one, m1 minus e into m2. So here u1, m1 plus m2 into m2, this one, 1 plus e into m2 divided by m1 plus m2 into u2. This formula only we have taken now. So we will get, that is the answer there. So by using that, we can find out that. So this one. Okay, like we can find out the second one also. V2 also we can find out there. V2 what will get here? 1 plus e into m1 divided by m1 plus m2 into u1 plus m2 minus e into m1 we got there. So by using that we'll get that answer. So next one is, second one is given here. A ball strike a horizontal plane with velocity v, rebounds with the 256 by 625 v. After fourth collision, the coefficient of restitution is. So coefficient of restitution. So here we got the formula, no? This one. So in nth, the coefficient of restitution they are asking there. In nth rebounds, what is the height reached by the body we got there? This one there, this right there. So now here they are asking there. A ball strike a horizontal plane with velocity v and rebounds with velocity 256 by 625 velocity after fourth collision. There. So after fourth collision, the speeds are given. This one Vn after fourth collision. Here it is. Then coefficient of restitution we can add here. E power n is equals to Vn by V1 we can add there. Vn by V1. So here they have said here. Strike the V1 velocity is given there. V is given, and here the Vn they are asking there. What is the velocity they are asking there? With velocity after collision. Rebounds, okay, it will be rebounds with velocity also is given there, 256 by 625 v is given there. Then coefficient of restitution, this e they are asking there. Okay, so how to find out? By using this formula we can find out now. Okay, we'll see here. So second solution. So Vn is equals to e power n into V1 we can add here. So here n is almost there, n is equals to fourth collision, and here V1 is given here V, and V nth. So V nth means V4 we can add here. Fourth collision of V4, it is given there 256 by 625 V is given there. Okay. So now we should find out the coefficient of restitution. Now substitute that value here. This is 256 divided by 625 is equals to, so e power 4 we can add now. So here n is equal to what there? 4, and here V1 is what there? This is a V and this is a V. So this and this will be cancelled there. So now if you want to find out E is equals to what can I do then? Fourth power of, so 256 divided by 625. So how can you write this one? So fourth power of, this is a 4 power 4 we can write now. 4 power 4 means 4 into 4 it is 16, 4 into 4 16, 16 into 16, 256 we can add there. Sorry, this is the 4, that is a 4 divided by, even it can be written as 5 whole power 4 we can add there. No, here we can add there. Then so 4 by square root of, this is also it is equals to 4 by 5 whole power, fourth power of this one, whole power 4 we can add there. So now from this E is equals to, so 4 by 5, 4 power of 4 will get, so this and this will be cancelled there. Okay, means this and this will be cancelled. How can we cancel that one? So fourth power means 1 by, fourth power means 1 by 4 will come now. So 4 by 5 whole power 1 by 4, and here 4 is there, so it will be multiplied, it will be cancelled there. So we'll get how much then? 4 by 5 will get there. 4 by 5 how much then? This is 0.8. So therefore, coefficient of restitution is what there? 0.8. So this is there in between 0 and 1, no? 0 and 1. So it is a elastic collision there. Answer is that one. So like this, based on all the formulas, these problems will be there. We can find out by using this one there. So 6 kg mass collide with the body at rest after collision. They travel together with velocity third velocity of the 6 kg mass. Okay, 1/3 of the 6 kg mass. Otherwise, it may be here given wrong there. So that we can find out that 6 kg mass is collided with a body at rest after collision. They travel together with velocity 1/3 of the velocity of the 6 kg mass. 1/3 of the velocity of the 6 kg mass. Then the mass of the second body is mass of the second body. Okay. So this one you see there here, fourth one. So based on this, all the formulas it will be there here. No? So fourth problem you see. Fourth one here, body is M2 body is at rest there, 6 kg mass. So M1 is given here. M1 is equals to 6 kg, and M2 we can write here. M2 is equals to, it is 0. It is at, okay, sorry. So that we need to find out there. This we need to find out, and it is moving with certain velocity. Let us consider it is moving with velocity v, and here this body is moving. It is at rest. U2 is, it is at rest there. U2 is at rest there. So then they are moving together after the collision there. So they are moving together means, so final velocity v1 is equals to v2 is equals to v. Okay. So and they have said here, moving with velocity 1/3 of the velocity of 6 kg mass. So what they have said here, 1/3 of the 1/3 means this one. The common velocity will be v by 3. So with what velocity it is moving there? V velocity is moving there. So 1/3 of the 6 kg mass of the body means v by 3 will get there. V by 3. So now what is the velocity here? We get there v1, v is equals to. So they did not mention here coefficient of restitution. So we will take the perfectly elastic collision. We can take that formula there. Okay. So what is the formula we got there? So m1 minus m2. m1 minus m2 divided by m1 plus m2. m1 plus m2 into u1 plus 2 into m2 into u2. u2 will be 0. No need to take this one. So we'll get what then? So we'll get, this is the equation only. And with what velocity is moving there? So this is a final velocity v by 3 it is given there, v by 3. And now right here this is a 6 minus m2 divided by 6 plus m2. m2 is what there? So m2 only right there, no problem. And here u1. So what is the u1? It is a v, no? So now this side this will be cancelled there. So what is the value we will get here? Multiplies, cross multiplication if you do that. 6 plus m2 is equals to, it is 18. So 3 into this one, 6 minus m2. So here we will get there minus 3 m2, and you bring this m and you send this that side. So we will get how much then? So it will become 4 m2 will get, and if you send this 6 that side, it will become minus, no? So 12 will get there. So therefore m2 is equal to how much you get there? It is a 4 kg. m2 will be the 4 kg mass. So like this we can find out. So fifth one is given here. A bullet of mass m by n moving horizontally with velocity v strikes a block of mass m and hits embedded into it. Embedded means same. So if it is fixed there, okay. So embedded means it will be fixed in other body there, okay. And velocity of the block is finally. So bullet of mass 1 by m by small n moving horizontally with velocity v strikes a block of mass small m and hits embedded into it there. After hitting there, it will be go into that block of mass small m. That bullet will be go into the mass of block small m. Then velocity of the block will be, means after they are stick together and moving there. So then we can find out the same formula we can use the inelastic collision formula. From that we will be get that equation there. Okay, final velocity of the block they're asking there. We can find out. Bullet of mass m by n is given moving horizontally with a block of mass. Strike a block of mass m. So that m2 will be m mass will be at rest there only. Okay. So it is not moving there. U2 we can take 0 there. So from that we can find out there. Same from the U2 will be 0 means we will get this equation only. No? From this only we can find out there. Same like that only. So you can do these all the problems, okay, by using this all the formulas. So then we will close this one. Then this is about the and remaining problems we will discuss in the doubt session. Okay. So then we will go to the next chapter here. That is the next chapter is work, power, energy. So this we will be start in the next class. Okay, in the next class. Tomorrow I am going to start this work, power, energy. Okay. So thank you children. Have a nice day.